An idempotent operation is one that can be performed multiple times without affecting the initial operation. In essence, this means that performing the same operation any number of times will have an identical result. This can be a very useful property for an operation to have in many cases in our software systems. The classic example of an idempotent operation is to think of elevator buttons. No matter how many times I press the button to visit the 5th floor, the end result will always be the same. It won't have any unintended side effects such as stopping the lift, visiting any other floors, or even getting me there any quicker, although that doesn't necessarily stop me from trying when I'm running late. So why is this important? Well, it means that an operation designed with idempotency in mind can be repeated or retried as often as necessary without causing unintended side effects. With non-idempotent operations, the algorithm may have to keep track of whether the operation was already performed or not. This can create unnecessary overhead both in terms of code and logical complexity, but also sometimes in other areas such as performance. Take, for example, an operation to update a record in a file of some kind. A non-idempotent implementation may need to perform two distinct operations. One to first read the file and execute some logic to identify whether the operation has been performed, and another to update the record if required. On the other hand, an idempotent operation would only need to perform one I/O operation, that is, to update the record. As another example, imagine the operations required in an e-commerce scenario. We would expect users to be able to add an item to their shopping cart multiple times, requiring a non-idempotent operation. However, when it comes to submitting orders or issuing refunds, it is important to ensure that the operations are fully idempotent. We would not usually want users to be able to submit the same order twice, or issue a refund to the same user for the same items multiple times. This second scenario is one which I have seen cost companies significant amounts of money in the past. Typically, a refund scenario, for example, will require multiple individual operations. Remove the item from the user's list of bought items, reallocate stock, issue a refund, update the finance systems, send the user an email, etc. It is important to be sure that all of these individual operations are truly idempotent in order to satisfy the idempotence requirement of the whole scenario. If one of those sub-operations is non-idempotent and a retry occurs, for instance, the unintended consequences could be costly. According to the W3C HTTP standard, of the major HTTP verbs, get, put, and delete should be implemented in an idempotent manner, but post does not need to be. Get should act only as a query. Reading data usually has no side effects. The put and delete verbs are used to either store or remove a resource. In both cases, the request should specify a location or identifier that uniquely identifies that resource for the entire lifetime of the system. Implemented in this way, the end result of the operation is always the same as the result of the initial execution, even if the response differs. For example, a different HTTP status code, such as a 404, may be returned on subsequent delete requests to indicate that the resource no longer exists. Post requests, which are used to create entirely new resources, do not need to be idempotent. Post requests often do not contain unique identifiers, so the creation of the identifier is delegated to the receiving system, which then creates a corresponding new record.